Hello and welcome back. For this playlist, I decided to work on a very common phenomenon in the realm of machine learning, which is the regression.
Nice.
And for the data set, I decided to download and work on a very pretty recent Kaggle competition. It was about premium pulse challenge, predicting financial risk. Develop a regression model that estimates the monetary cost of financial coverage products based on a variety of customer attributes. And make sure to check the link. I will leave the link in the description below. And the dataset consists of three parts, three CSV files. One is a sample submission and train and test. Let's check the train here. Yes, if I move my picture up a bit, you can see it better. Yeah.
2,000 years later.
For the training data set, we have about 20 features. One actually is the target. We have different features for each person. Note that each record allocate for each person. So we have about gender, income, occupation, health score, blah, 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 blah. And our target is the premium amount. For your own study, you can actually consider this case as an unsupervised case and try to actually cluster the customers into different categories. But for this playlist, I decided to work on a regression so that we could predict the value for premium amount in the test dataset. You can see that technically in the test dataset, we don't have the premium amount. So the target is definitely the premium amount. A credit score for each person. Are they high risk or low risk in terms of a quantitative amount? And that's it for the data set. But note that we don't have much of an explanation about the features. Unlike other data set, you might see a lot of description here about the data set. But for this specific Kaggle competition, we don't have much of an explanation that will cause some sort of challenges in as we go further. For example, the annual income, it doesn't have any clear monetary unit. It doesn't clear that it is in yen or it is in US dollar, it's in Canadian dollars, and that could cause some sort of real world problems. And we're going to see those challenges as we go further. And note that we're going to work from scratch. We have pre-processing, we have missing data handling, we have outliers handling, we have encodings and different things. And then we're going to create models after we clean our data and go through a whole process of the pre-processing for the data set. Then we're going to create a model and we're going to evaluate our model. So without any further explanation, I will see you on the Jupyter Notebook. Stay tuned.
2,000 years later.
Okay, now we're in Jupyter Notebook. We're going to start off by importing some usual packages. I'm going to import pandas, pandas as PD. I'm going to import numpy as np. I'm going to import matplotlib, lib, yeah, pyplot, pyplot as plt. I'm going to import seaborn in case you want to create correlation tables. Seaborn as SNS. Import one other package that I'm going to import is summary tools. Basically, summary tools will give you a really great statistical summary for your data frame, and the installation process is really straightforward. You just hit pip install, install summary tools, and hit enter. It installs straightforward, and you can import it easily. So I'm going to import summary tools as st and import warnings just to filter out further warnings. I actually mentioned the codes instead of the mentioned upgraded code, so you cannot you can avoid actually getting warnings for future updates of Python. So warnings, dot filter warnings, warnings. Let's say ignore, and that's it for now. So I want to start off uh, importing my data frames. So the training data set that I'm going to use, I'm going to name it df train, and I'm going to say pd dot read, dot read csv, and I'm going to find my csv file. Okay, uh, hold Control Shift C to copy the path, and uh, for pasting your directory easy, you just hit R and paste your directory path. Note that if you don't want to use R, you should change all of the backslashes to forward slash. And instead of doing that, it could be really time consuming. So just add an R before the double quotation of your CSV file directory, and then hit enter. It will be automatically check your directory and import your CSV file. I'm going to do the same for test. So it's going to be equal to pd.read CSV file, and hit R. Let me just copy my CSV file directory, and yeah, that's it.
A few moments later.
I'm going to just check df train the head. I'm going to check the top rows in order to be sure that data frame imported correctly. Yeah, you can see that our data frame imported correctly. We have ID, age, gender, annual income, all the way up to the premium amount, which is our target. And let me just check the test data set too, the head. And yeah, we have ID, gender, annual income, all the way up to the property type. So we don't have the premium amount since it's the target, and we should predict it based on these 20 features. Okay, now just let me use .info command. .info, info, just to check the amount of data that we have. Df test .info. I'm not really using the output here, just to see how many data that we have, how many records that we have, and how many memory usage each CSV file consumes. So our training data set has about 1,200,000 records, and it takes about 192 megabyte of our memory. And our test data set is about 1,800,000 records and takes about 122 megabytes of our memory. So now we're going to use the summary tools, df summary, which gives us the statistical summary about our different features in a data set. And it's really cool because instead of using different codes like df describe or other thing to measure a statistical measurement of different feature, you can just simply use st.df summary and give a whole lot information about your features, and it's really useful for your ADA analysis. So I'm gonna use df underline train, so you have to pass a data set to it, and it might take a bit long, so I write the same code for my test data set, df summary for df train. Oh, I'm sorry, for df test. And let's wait till the first one gives us the output, and then I'm going to run the second one. Okay, let me just run this. Oops, summary tools has no df summary. Why? Let me just see if I copy it wrong. No, it's okay. So what's the problem? In case, yeah, that's a st. Okay. Anyway, so let's check the information that summary tools provides us. I guess the second one. Yeah, that's correct. I am the way your son don't need. Okay, now we have ID, we have the mean and the standard deviation of these values. We have mean, median, and maximum. The mean is 0, and the maximum is wow, 1,199,000. I don't know, the number is really out of my league. We have IQR, different between third quartile and first quartile. And you can see the graph. It looks exactly like a uniform distribution. We have no missing value since it's ID. It's really normal, and it's not really significant in our data analysis and modeling. And we have age here. We can see that we have the minimum, we have the mean of 41.1. The standard deviation of age is about 13 and a half. The minimum value for age is 18, and the maximum is 64, which is really natural for a data set that is about banking or about credit, financial credit score or financial risk, since you should be in the legal age to have this kind of opportunities to use bankings or things like that. And so it's pretty straightforward. There's no really outlier values in the age, like someone with the age of 100 or even 70 or even 75. That's really cool. And the IQR is about 23, and the coefficient of variation, which is uh, the coefficient of variation, which is the your standard deviation divided by mean, is 3. And the distribution is some kind of uniform distribution, and we have 1.6% of data when missing, which is not really much. It's okay. 18,700. Yeah, that's from our age. In gender, we have two categories. We have male and female. Around 50% of them are male, and around 50% of them are female. There is no missing values here. It's really cool. Just look at these two proportion. They're relatively balanced in relate to each other, and that makes our modeling really easier. In real world problems, you might see that we have really unbalanced proportion of men to women, or vice versa. For example, we might have 18% of the data set for men and 20% for women, which makes our data frame really unbalanced. But in this case, most of our features are really balanced, and that's really makes our life easier. So yeah, that's it from our gender. Annual income. The annual income, we have the mean and the standard deviation. The minimum value for annual income is 1. The annual income is 1. And the maximum is about 150,000. We have about 3% of data went missing, but consider that for a moment, that we have two major conflicts here. One, we do not know the monetary unit of the annual income. We don't know whether it's in Japanese yen, or it's in Australian dollar or Canadian dollar, or whatever the monetary unit is. And the other thing is the values. We have some noisy values. No one in the real world, you will see that have the annual income of 1 or 2 or even 10, 20. We have all these values in our data set that someone stated their annual income as 1, 2, 13, 14. There might raise some different scenarios and some doubts about the data set, but we should try to manage those in the future videos. And yeah, that's it. That's one of our challenging features that we have here, and it should be fixed. The amount of data when missing is about 3%, which is not really much. And one important note for these values like this could be the data just someone who would record the data. It might be a algorithm or a computer that does not accept zero for valid income values. Maybe some people are unemployed that they didn't make that much, but when they input their annual income as zero, system raise an error. That's why they use these values: 1, 2, 20, 5, even 10. These values are not really plausible or valid in terms of $150,000 or 150,000. We don't know the unit. Yeah, that's our problem in this feature. Next one, marital status. We have single, married, divorced, and about 1.5% of data went missing. And just take a look at the proportion of each category in relate to other. They're really, really balanced, and that's really good. Yeah, that's okay. For NaN values, note that always do not consider NaN as something that is unfilled. Mostly NaN values are have meaning. For example, considering this data set that have about consider instead of these NaN values, we don't have any married category, and 32.9% of the data went missing. In that case, you can see that you have single, you have divorced, but around 30% of the data doesn't have any specific category that is really meaningful and insightful. So you can just change those categories to actually married if other features are really meaningful using this category for their marital status. I mean, you just consider other features and you see if it is fits to a married person. You can just change the NaN values to a new category. That would be a really good way to actually use your data in the modeling instead of changing it to single or divorced. In case if your NaN values are significant and it's really obvious that one category went missing, this could be a really useful way to use. So in this case, we have 1.5% of data went missing, and we're going to use other categories to fill these values, and that's it. We have number of dependents. Note that number of dependents might have different meanings in the banking sector or any credit, financial credit score. Make sure to study a bit about the number of dependents itself. And unfortunately, in the dataset description, there is not much of explanation about this feature. So in this feature, we have different categories from 0 to 4, and we have 9.1% of data when missing. And again, all categories are really and perfectly balanced. That's really good. And yeah, there's not much to talk about in this feature. And okay, moving up to this next feature. Next feature is really good. It's education level, starting from high school all the way up to PhD. It's a ordinal feature. It means that the order matters, and there's no missing values. The data is really balanced, and it's okay. Occupation, we have employed, self-employed, unemployed. The proportions are exactly balanced. There's not much of an unbalance, but note that we have about 30% of data went missing. In this case, if you go through dataset and look for yourself, you can see that many people in the age of 18 to 22 or have NaN values as their job or occupation here. This could be rise the belief that those people might be students or college students or things like that, that they might not have any specific job to do. But if you consider those categories as new categories and add them next to others, the proportion of those categories will be really small in relate to others, like for example employed or unemployed. So considering new feature for this considering new categories for this feature is not really good. For example, you can consider people above age 55 as retired if they don't have any occupation or their occupation filled as NaN, but it's not really proportional in relate to other amount of data. So I just consider this NaN values to be filled with these same categories, and I just don't want to add other categories. One other thing that you can do is actually consider this feature as a binary feature and divide people into two branch. One of them are employed and one of them are unemployed, and then fill your data set based on that. Fill the NaN values based on that, and then check to see if the model gets better or not. That's up to you. If you like to use that, you can use it. I didn't try that, but it could be a plausible and logical way to somehow get rid of this amount of NaN values. And yeah, 30% NaN values in the occupation. Another feature is health score. We have the minimum value 2 and the maximum 59, and distribution looks okay. 6.2% of data went missing, and exactly if you just check the test data set, you can see the exact amount of missing values here. Damn! And it's really good because there are relatively same proportion when missing in both train and test, and in real world problem that might not be really like that. You might have missing values around 3-4% of data in your training data set, and around I don't know 14-15% 40-50% of data set when missing in your testing data, and that could be a pain in the neck, but in this case that's okay. We have location, suburban, rural, and urban, perfectly balanced, no missing values. Policy type, three categories, and perfectly balanced, no missing values. That's really good. And previous claims, we have very different categories here. Note that around 30% of data went missing. On the other hand, we have 50% of data categorized into two categories, which is 0 and 1. You can see that we have 30% of data when missing, okay? 50% of data in two categories, so that's aggregately about 80% of our data. And other features, other categories are really less in the amount of the proportion to other categories, to first top three categories, and that could be cause our modeling to have a malfunction scenario, having a bit of malfunction on these two categories, 0 and 1. So we should consider a scenario in our outliers and missing data handling to actually some sort of playing with data to make the data balanced. Maybe we can just add other categories to number of dependents with I'm sorry, add them to the previous claims of 2, so that we could be somehow balancing the data set. And you can see the amount of unbalanced data here. Out of 100 million record, more than 100 million record, I'm sorry, more than 1 million record. We have one previous claim record that is stated as other. We have 58 records stated as 6, and that would be cause a lot of problem if we don't balance our data.
No, God! No, God, please, no! No! No!
And that's it from our feature. We have 30% of data when missing. Yeah. Vehicle's age, minimum value is 0. Maybe they bought it this year, uh, and it's pretty brand new. And the maximum is 20. It's perfectly almost a uniform distribution. We have 6 missing values. We can fill it with the mode or the media, and there's no really difference in relate to the whole data set. 6 values is about 0 actually, as it stated. Credit score, continuous feature, minimum is 300 and the maximum is 849. 11% of data went missing. That's okay. We have here the insurance duration. Insurance duration logically and technically should be stated in months. No one's gonna insure their car or their property for 9 years, and no insurance company accepted agreement. So technically they should be in months. They're perfectly balanced. There's no unbalancing here. None of the features are really higher in terms of proportion than others, and that's okay. We have only one missing values. We can fill it with one of the categories. Does not really matter. It's just one missing one missing record. And policy start date, I just don't use this feature, and I might get rid of it later on, because considering the time and date would be turn our data set into some sort of a time series thing, which is not really the case of this playlist. But if you like to use it, you can use it for your own and in your own time, play around with the data and see how it actually affect on your results. But in this case, I just try to skip it and just eliminate this, because um, it's not really helpful. It might cause error when we want to normalize or standardize our data. So that's the feature that I'm not going to use, and I might get rid of it. Next, we have customer feedback. We have average, poor, good, and none values, perfectly balanced. We can use the same categories to fill this 6.5% of data when missing. And smoking status, binary, 50-50, no missing values. Exercise frequency, it's a ordinal. Keep it in mind, this kind of feature is ordinal, because the orders start off from daily all the way up to the rarely. In this case, the features like this, when stated once a week, twice a week, daily, monthly, they're ordinal. They're not categorical or nominal. The order have meanings in this kind of features, so consider that as a ordinal feature. No missing values, it's okay. Next, property type. We have house, apartment, condo, perfectly balanced, no missing values. And last one is our target value, which is about which has the mean of this value, and this is the standard deviation, minimum 20 in terms of the premium amount, the credit score, and the maximum of nearly 5,000. Yeah, that's it from our training data set. We have exactly the same a procedure for our testing data set. Make sure to check the records row by row in the DF test here, and because we're not going to be really focusing on DF test like this, It's exactly like the same. Most of them are proportional. And yeah, that's it for this video. For the next video, we're going to talk about the correlations between the feature. We're going to look for a statistical meaningful relationship between the features, if it is meaningful or not. And yeah, that's it for this video. I hope it could be useful.